Come on, man. 5.099.
So, just to kind of go back over this for anybody who missed it last time. Square roots are the opposites of, if I take 8 and I square it, what do I get? 64. So 2 8s multiplied makes 64. Right? So section 6.4 comes in and says, okay, there must be, math pretty much always has a way to go both ways. Right? So don't judge it. Right? Leave it alone. It's got its own decisions to make. But it's always able to go both ways, and it wants to represent those directions with 2 different symbols. So if I want to tell somebody how many of a number to multiply, that's an exponent, right? I put the 2 up there. It's got a little spot. That's the symbol for multiplying something over and over again, is a power. So if I want to do the opposite of that, if I want to take a number and split it back up, so you can take 64 and split it up into 2 8s. That's what section 6.4 is about. It says square root of 64. And because it's a square root, I know I'm talking about splitting 64 up into 2 parts, right? What 2 numbers, what number multiplies by itself? So 2 of that same number makes 64. And of course we know it's 8. So in a way the square root is cutting something down, whereas a power is building it up. So the really, well, I'll do this in a little bit. What about square root of 144?
12.
Good. Right. So obviously the better you know your squares, the easier some of these are going to be. So this is 12. Why exactly is that 12?
12
by 12.
Yeah, because this says what do you take 2 of to multiply to be this, and of course you take 2 12s to multiply to be 144. I love it. So with a lot of mathematics, math is a different language, and it's just understanding what these symbols represent. What question do they represent? So going back to this one here for a second, I went a little bit further last time than the square root. All right, we looked at some problems that went beyond that. What would that symbol mean?
Oh, yeah.
It does not mean 3 into 64. So I try to get that 3 to sit in there. That's different from division. It kind of sucks that they made it look a lot like a division symbol. But we just have to deal with it. We weren't alive back when they did this. So we're just like, oh, well, we missed that meeting. But what question does this symbol ask? So this one asks, what does it take 2 of to make 64? What does it take 2 of multiplied to get 64? This one asks, what does it take 3 of to make 64? Now, think about it. What do you multiply 3 of? What number?
4 times 4.
4 times 4.
There you go. 4 times 4 is 16, times 4 is 64. So if you broke this thing down, it takes 3 4. So the answer to this is, cube root of 64 is 4.
But that would be 3. Maybe you may know.
What you've got to be careful about. I really want this to make, even beyond, just don't just listen to the words and go, great. Really understand what I'm saying. If you know what the symbol is asking, what question does the symbol take the place of? Math people don't like to write a lot. I'm not going to write, what does it take 3 of to multiply to me? No, screw that. I'm going to make up a stupid little symbol that students have to learn in the future. And I'm there, so too bad for you. You weren't there, so this symbol now, we all have to understand the question that it's asking. This symbol is asking, what does it take 3 of to multiply to be 64? And it takes 3 4s to multiply to be 64. So it's not, you can't base this on something, it's not division, so you got to be careful. It's something new. And whenever you learn something new, you just have to, in mathematics, you just have to go, okay, what is it asking me to do? And how do I do that? So that's what these kind of things are asking you to do. It gets a little bit weird quickly. Like if I said the fifth root of 32, can anybody tell me what process I might try to do to find the answer to that?
5 times. You do
2 times 2 times 2 times.
What did I do here?
You do the tree thing.
Yeah,
Oh, that.
we're going to catch up to you.
2 times 16 is
2 times 16,
2 times 8.
2 times
2
8.
times 4, and then 2 times 2. So it would be,
So what does 32 take to make it? It takes 1, 2, 3, 4, 5 twos.
yeah.
So what question is this asking?
How many of those?
What does it take 5 of to multiply to be 32? So the answer to that question is 2. It takes 5 twos to multiply to be 32. The better you understand the question that the symbol represents, the easier the problem is. There is no, you can't look at that and work it. You have to know what this is asking you. And what it's asking you is exactly this. What does it take 5 of to multiply to be 32? We just found out it takes 5 twos. So the answer is 2, not 2 to the 5th. It doesn't just rewrite 32, it breaks it down to its parts. Right? So I have 5 twos make 32. How we doing? Now the other way around, the opposite of fifth root would be a fifth power. If I took 2 to the fifth power, that makes it 32. So I start with a 2 and I apply this to it and it becomes 32. If I start with a 32 and I apply the opposite, I end up back where I started, back at 2. They are opposites of each other. Hopefully.
Yeah.
Yes, sir.
Not 6.
Not 6.
That'd be made of 2.
No, it's not division. It's not. This is the 5 goes into 32. So I'm with you. That would be 6.
That'd be made
Blah,
of
blah, blah. This is something entirely new.
2.
That means the fifth root of 32. It doesn't ask you to divide the numbers.
So that'd be 2.
This would be 2. Because it takes 5 twos to multiply to be 32.
Okay.
I like it. Okay, cool.
It's weird.
It is weird, but it's cool. All right. Just to make sure you guys understand, I always do. I like to take that one extra step. The book only talks about square roots. You're only going to deal with square roots. Math 90, Math 110, 103, whatever. You're going to deal with higher level roots. 8th roots, 9th roots, 12th roots. Oh yeah. So, let me see. If I had a problem like this.
Should be 3.
3.
Good. It's not the square root of 13.
That's 36.
It's square root of 9 is 3. Well, square root of 4 is 2. 5. I like it.
Good job.
Big ass. Because square roots, now, whenever we learn a new function, a new operation, a good question should be, where the hell does that go in PEMDAS? So roots are the opposite of exponents, so they actually are at the same level. Roots are at the exponent level. You have to apply them. So would I do the square root first or the addition first? Of course I would do the square root first, because it's way up above addition. You guys kind of with me? So whenever you learn a new function, you have to also know where the hell does it go in the order of operations. Or else I don't know how to simplify these things. Okay. How are you doing so far? Yes, sir.
So that's 36.
No, it's not 9 times 4. It's this plus this. And this symbol means, what does it take 2 of? There's an understood 2 in there. So this is part of what we talked about last time is these roots. The square root, we don't write the 2. Because it's the most used one. So we're like, we can save a lot of time if we just don't write a 2 in there. So if you see a root without a number in it, you know it's a square root. Yay. Cool.
What does the E mean again?
What does the E mean again? Exponents. All right. Not powers. Then we have like a PP. Please pardon, my dear. No. Right. That actually works, but no. It's no good. Okay. So how do you guys feel about that? I mean, once you see the idea, it shouldn't be that hard afterwards. We even did some with fractions in it last time.
Fraction.
Remember that? So we had something like square root of 25 over, what you got, Jeff? Let's do something freaky. 121.
5 over 11. 5 over 11. 5 over 11.
Exactly, right? Because it's 5 times 5 is 25. And what does it take 2 of to make 121? 11. To check yourself, you just, what do? You take 5 11s and you square it. Square root is the opposite of square. So if I apply a square to my answer, I should get whatever the hell's inside there. I do the opposite thing to kind of check it. Yes, sir.
Okay, so just put the 2 and then put the 25 out of 121.
So what you're really doing, and I like to say this, let me get this out of the way right now in case I do say this, because I say it all the time. A square root splits a number in half. But when I say that, I mean, if I say square root of 9, what's that? 3, because it takes 2 3s to multiply by 9, right? So effectively, I split 9 in half multiplicatively. 9 is 3 times 3. But if you just split 9 in half, you get 4 1/2. That's not what I mean when I say that. You guys kind of with me? So root, a square root splits something in half multiplicatively. So root 25, split it in half, 25 is 5 times 5. So root 25 is 5. 121 is 11 times 11. So split it in half and you get 11. Yes, sir?
And then you put the 3 and put the 2 on top. On upper 9.
For this guy?
Yeah. Put the
There's an
3.
understood 2 there.
Yeah.
Good, because if it's not there, I know it's a square root. It's a second root.
Yeah, but you put the. Can you put the 2 and put the 3 and put the 2?
You know, here, right here, this is 3 squared. But the square root of 9 is 1 3. Because the answer is going to be, what does it take 2 of to make 9? And it takes 2 3s to make 9. Cool. Yeah. It takes 3 to make it out.
Can be
Yes, sir.
small, right?
If you put 5, just like 5, a fraction like 5/16, and you square it, but you have the parentheses there, or whatever.
So if I had 5, let's make it 5/8. Just make it, and you square it like that?
Right, my question is, if I wrote the 5 inside the parentheses, or the 2 inside of the parentheses, that doesn't mean the same thing?
Definitely not. It
That
depends.
means just the 5 you're squaring?
Because right here, what's the square sitting on?
The whole thing.
The 5/8.
So
Because that parenthesis kind of groups it. If I wrote it like this, what's the square sitting on?
The 5 only.
5 only. Good.
Alright, ignore that in my homework, okay?
That might prove difficult, considering that's my whole job.
Just pointed it out.
Yeah. Especially now they made it very obvious. So I'll be looking out for that. Sorry, I do the exact opposite of what you just told me.
So I got a reason.
Okay. And real quick, the last little thing that you'll see in the homework is if they give you, now obviously every number I'm choosing so far, I've carefully chosen. Because I know it comes from some number squared, right? So I haven't done something like put up here square root of 11. Because that would be evil. Because you cannot come up with an answer by hand. But you can come up with an approximation. You can figure out what is it about. So 11 is in between what nice numbers for square roots?
10 to 12. Or no,
Square root of
9
9 I can do, right? I can do square root of 9.
and 16.
And I can do the square root of 16. So since the square root of 9 is 3, the square root of 16 is 4. Square root of 11 must be some decimal in between 3 and 4.
Just guess 3.317.
So then you can put that in the calculator and figure out what it is.
That's what it is.
There you go. Does that make sense? I don't want you thinking that every square root is nice just because I'm picking numbers that work really nice. I'm doing that just so we get the idea. But if I pick a number that's not nice, a number that's not some other number squared, it's not going to work out nice. Yes?
It's not like 5. the 1, 5, and then you put the 6, and then you take the 6, and then take the 4, and then you remain the 4, and then you take
No,
the 4.
no. The minute you say remainder, I think, and you think it's division still. It's not division. It's not division.
Actually, if you take the number 25, you gotta go all the way to number 64 before you get another one. That's what this paper says.
That paper's crazy. You just got to go to 36, right?
Oh, that's on the bottom.
So a really, really good idea.
I gotta take these together, you're right.
Got a really good idea going into this section is just to take a second and make a list of squares. 2 squared is 4, 3 squared is 9, 4 squared is 5 squared, 6 squared, 7 squared, right? So you should know at least up to 12. Maybe push it, try to see what 13 squared is. Anybody know?
What?
169, good?
What?
What?
Yeah.
Keep going with his list, is my basic point.
Oh, okay.
Because then when you see square root of 49, you know it's 7. You're just making sure that you know those squares. Okay, cool. Maybe. All right. Now, immediately after discussing square roots, something that we talk about is the Pythagorean theorem.
Oh man.
Oh, yeah.
Oh, that's Star Wars, right? Is it a real word?
Yes, it is. The triangle, right?
So it's this old Greek dude named Pythagoras. And if you read the history, Pythagoras had a lot of followers. And he made the followers do a lot of the work, and he took all the credit. Now he did some work. He did do some work, but he had his followers do a lot of work for him. But he got his name on this theorem. And this theorem, now, has anybody heard of this theorem? It sounds like a few of you guys maybe have. All right, and the rest of you are all like saying, you just make that word up. And what this deals with is this deals with right triangles. Yes, sir.
What is a right triangle? Has a 90-degree corner.
I love it. That was my next question. So this word right means that there must be a 90-degree angle in that triangle. Aw. Now, anybody know the angles in a triangle? Just off the topic here a little bit.
3, 4, 5, 6, 8, 10.
The angles in a triangle have to add up to be what?
Yeah.
If I have a rectangle, every single one of these is 90 degrees, right?
Yeah.
So how many total degrees in there? If I take a triangle, it's basically 180. Good. So every triangle has to have 180 degrees in it. Cool. All right. So, don't worry, we're not going to get too deep into geometry yet. Geometry has its own section coming up. What this theorem deals with is something kind of weird. If I had something that was 3 inches long here, and then something I laid right next to it 4 inches, now of course that would be how long? 7. But the minute I start to lift this thing up, and I talk about how far apart the ends are, so here the ends are 7 inches apart. If I lift it up a little bit, this side here, how far apart are these? It's not 7 anymore. You guys with that? Isn't it getting a little bit closer?
Yeah.
And if I took it to the extreme and just took it all the way down, and so I laid the 3 this way, and the 4, so the 3's right on top of the 4. Now how far apart are these? This is 3. This is 4. What's this?
1.
1. I love it. Okay, so what Pythagoras said is, okay, right when it's right here, right when it's in between the least distance and the most distance, that's when something very interesting happens. And I know it's not the straight up addition. We already know it's going to be less than 7. The minute I pick this dude up, it's getting closer and closer to the other side, right? Is that, you guys with me? It's kind of nifty. So here's the cool thing about this. If I have a triangle, a right triangle, with sides A, B, C. We're not going to do a full proof, but I want to show you a nifty visual as to why this makes sense. If I drew, just go with it. If I drew a square off of this side, you guys see what I'm saying? I want to draw a square off of that side. Like that. How long must this side be? If it's a square, how long is this side?
90.
No. How long is that side?
60.
A. Good. So how long must this side be?
A.
A.
Maybe. Oh.
And I want to lay a square down here.
Baby.
It's going to be B. Right, incredible one. And then if I lay a square down here, oops, it's going to be C by C. Now what's the area of that square? A times A is A squared. I love it. What's the area of this one? And what's the area of that one? Now what is really funky is if you take any triangle like this and you take this area added to this area, you will get that area. That's the basic idea of the Pythagorean theorem. So it says the two smaller areas added
Equal the longest.
equal the bigger area up there. Yes, sir.
That's like ABC 8.
I'm not sure.
ABC 8. 2, 4, 8.
No. So it could be anything. So coming back to that triangle we had a second ago. We had, remember I started like this. This was 3 and this was 4. Now if I pick this guy straight up, so now I have 3, 4. Do I have a, no. Randy, did you have a ruler?
No, I forgot it.
That's all right, that's all right. So if we do this rule, what would this square's area be?
3.
2 squared.
3 times 3 is? 9. What would this square's area be? 16. So what must this square's area be?
9 plus 16, 25.
9 plus 16?
25.
It must be 25. Just a second.
Hold on.
The square root of 9 is 3, and that's that side, right?
Yeah.
So if I square 3 to get 9, I can square root to get back, right? So 4 squared is 16. That's where I got 16 from. 4 times 4. Square root of 16, of course, is 4. That's where it came from. Now this side, I don't even know that side. But I know that its area must be 25. So how long must that side be? The square root of 25 is 5.
So you want to do all of them square, or we have to do them like 3 or...
So the rule says, if you want to see the math of it, if I give you a triangle like this, and real quick, which side will always be C? Which side will always be the longest side?
The long side.
The one that's across from...
The two short sides.
I love it.
The 90 degree.
Exactly. That's going to be your biggest angle in there. 90-degree angle is going to be the biggest angle. So if that's the biggest angle, it shouldn't have the largest side across from it because that's where it opens the most. This angle is not going to open as much. And this angle is not going to open as much. Why? How many total degrees in a triangle?
180.
180. So if this is already got 90 of it, these two together are going to be 90. So neither one of them is going to be as big as this dude. You guys with me? So he's definitely the biggest. He opens the most. He's got the biggest mouth. So I can fit in the biggest side there for him. Right? This is always going to be the biggest side. And look at the equation. If these add to get this side always has to be there. It's the biggest one. It's the one that the other two add to be. Yes, sir?
So the two smallest sides are always equal to big sides.
Exactly. So, and I'll show you why this is really important, because if they give you a number here, you have to know where to put it to make it make sense. So, mathematically, how would I do this? I could call this A, I could call this B. A and B don't really matter. They just have to be the other two legs. So, A is 3, so I get 3 squared plus 4 squared equals C squared. Now, how do I work that out?
9.
Good, you got to square before you add. I love it. So 9 plus 16. 9 and 16 is 25. And then I do a square root. Square root of 25 is, the square root of c squared
No, see,
is just c. It's almost a silly question. What does it take 2 of to multiply to be c squared? Well, it takes 2 freaking c's. That's what the 2 means, right? So the square root of c squared is going to be just c. That's what it takes 2 of to make c squared. So now I know this side is 5. Yes?
So that's like 1, see?
Yes, it's like 1c. I love it. So then you know what that last side, you know what this last side is. You know how long it is. It's kind of neat. Not all triangles are going to be nice, like 3, 4, 5. Right? So I can make, very quickly, I can make an ugly triangle. Poor little dude.
Uh-oh.
So using the rule.
2 square plus 5 square.
Yeah, so I know that a squared plus b squared equals c squared. And the side that I don't know, I know that's got what letter? C. So fill it in. Like you
2
said.
square
2 squared
plus 5 square
plus 5 squared.
equals 6. 4
4
plus 25 equals
29.
C.
29.
Now to kill the square, what do you do to both sides? Take a square root. I love it. And how do you always, real quick, I desperately want you guys to get this. How do you always solve an equation? You do the opposite, right? And my c is not by itself because of the stupid square, but what's the opposite of a square? Square root. So the process of solving equations doesn't depend on what's in there. Whatever's in there, you just always do the opposite. So the opposite of square is square root. So then you get c is whatever the hell that is. So on the homework, you will get some that are not nice roots. And they will say, go ahead and make it into a decimal. So can you guys get the square root of 29?
5.3.
5.3 roughly?
Yeah.
Which makes sense because 5 would be 25. So a little bit more than 5 would make a little bit more than 25. Good.
We should have used our calculator to do that.
Say again?
We can do it by our hand.
No, you can't. You got to trust me on that.
So we should always use our calculator.
Not always. You can do like square root of 25.
These numbers.
For that one, yeah. Definitely.
But not 3?
Not 3. Because 3 times 3 is nowhere near.
3.5? Not 3.5?
Nope. Square root of 29 is a little bigger than 25.
So that you made it,
No remainder. There's no division.
really?
Really. So Randy, real quick. Square root of 25.
5.
Beautiful. So doesn't the square root of 29 have to be a little bigger than 5? Because 29 is a little bigger than 25?
36.
Not quite 6. Because what's 6 times 6?
36.
So the square root of 36 is 6.
Yeah.
So the square root of 29 is going to be somewhere in between 5 and 6.
4.
4 is not in between 5 and 6.
3.
Good try. So it's got to be some decimal. It comes out to be about 5.3, blah, blah, blah.
So the only way you're going to get the answers is the calculator.
Exactly. Unless it's like square root of 16. And then you can do that, right? Otherwise, so there's a lot of numbers you cannot do, and there's only a few that you can't. Just those perfect squares you could do. So what if I had, here, I'm not going to say a damn thing.
Okay.
Uh-oh.
I got this. Easy.
3 square plus.
Now you do me a favor and don't say a damn thing either.
Is that a B?
Uh-oh.
That was really nice. Why was I really nice? Anybody know? How was I really, really nice in this problem that I'm not always going to be? I've labeled this as B. So in the future, I'm just going to have, like an X here. How do you know where things go? The only thing that's the most important is the one that's C. Good job, Danielson. The other two doesn't matter because you're adding it. It doesn't matter which one you call A or B because they could just flip around anyway. Who cares? So which side here is C?
The 8.
The 8, because it's across from the biggest angle. So you know 8 is C. Then you can call these whatever the hell you want to. Because they're going to end up on the right side. So I can call this A, call this B. Yes, ma'am.
Yeah. A squared plus B squared equals C squared.
Kick-ass. And now that we've figured out which parts everything is, I can just plug and chug. So in place of A, I'm going to put 3.
3 B squared plus B squared
Yes.
equals
8
squared.
Good, right? Yes, sir.
That'd be 4.
Can't be 4.
Because 4 times 2 times 2 is 4.
I love it, but nowhere in here does it say what is 2 times 2.
4 times 2 is 8.
What's 3 squared?
9.
9. So I got to solve this equation. 3 squared is 9. Plus this thing I don't know.
64.
Right? So we all know how to solve equations. What's in the wrong place?
9.
9.
55.
55, I love it.
But hold on.
Another.
That's X squared though. So 55 squared is that what?
No, be careful.
So now you're just going to
This,
square
now listen. What this says is, what squared is, guys,
55.
what squared is 55? So 55 squared can never be the answer. What does it take to square to make 55? That's what it's asking. And isn't that exactly the question that the square root asks? That's why it makes sense. I want to take a square root. What do I square to get 55? I don't know. Shit, I'm going to have to put it in my calculator. But to actually do the work, I do a square root.
Oh no, that's good.
Because what's the opposite of squaring? Square rooting. And so these actually cancel each other. That's kind of nice. If I divide by 2, I multiply by 2 because those two would cancel. If I'm squaring something, I can square root it because those two would cancel. They are the opposite of each other. Yes?
Be 11.
No, it's not 55 divided by 5.
Not even 5.
No. You got to plug it in your calculator, or you could give me an estimate. Square root of 55 is in between what two nice things?
64.
Square root of
7.
49. Square root of
8.
So I know it's in between 7 and 8. So if you plug it in the calculator, you get
7.4.
7.3 something.
3-4, I think.
4.
7.3 what?
3-4.
7.3144.
Oh, 7.31. Oh, you guys are changing.
7.41.
We got dissension in the ranks.
So the X really doesn't have any value there. Basically, it's just
7.416.
Okay, good. Thank you. Blah, 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 blah. And that's an example of a decimal that would never end. So I'm going to have to tell you where to round it. So you don't go crazy trying to copy it from the calculator. But do you understand how the most you could do by hand is give me an estimate? It's somewhere between 7 and 8. To get the exact answer, you need a calculator to do that. X has a value that I don't know yet. So now you see the utility of the whole equation solving process. From this geometrical problem, I got an equation. If I solve it, I figure out what X's value is.
because looking at it, if you 3 times 3 and 8 times 8, if you subtract the 2, you can see it right there before you do anything.
Okay, sure. Yeah. Because if you understand the idea behind this, then you can apply it. I love it. So the equation kind of gives you a framework to work within. But if you know the idea behind this, you could apply that more directly.
Well,
It's fine.
is it every time the X going to cancel out like that, or sometimes it, is it going to be different, or is it always going to be the same? So it's X. by itself like you have it.
Oh yeah, you can always get to that point, right? You subtract the numbers away, you take the root to kill the square, you can always get there. With these right triangles, no problem. They're just going to give you different places where you don't know. You just got to make sure you plug the numbers in the right place. Make sure that the biggest dude is by himself on the other side.
Now what if you had the X on the long side and then the 8 at the bottom?
That would be like what we did over there. Right? And I didn't call it X, I called it C, but it's still over there by itself. The long side has got to be over here by itself. Cool. Yeah, you good?
So the long side will always be on the right?
Because what does it take to make the long side? It takes the sum of these squares of the other two to make it. He's the biggest dude. The other two have to add to become him. Does that make sense?
It makes perfect sense.
I like it. Yes.
That'd be 2.
No. What would be 2? We know the answer is here.
Yeah, but it's 2.
No, 7.416.
Not 2?
No.
That's you.
No. Okay. So we're going to get a little bit into chapter 7. Yep.
More evil.
Now, you guys tell me, where do you run into percentages in everyday life? Besides your math class, where do you run into percentages? Budget. Stores. In what way? Sales. Exactly.
Computer. Well, because I do like testing and stuff.
Yeah, that tells you the percent done or something, or the percent of the hard drive that's left. I love it. Budgeting. How much of your budget, what percentage goes to this? So what I really want you to understand is going into this is this fact. Guys, hey. Percentages are completely made up, not made up, I gotta be careful. They are a representation of a number that humans have made up so that it makes more sense to us. So a percentage is always going to be out of 100. But I don't always have 100 things. So if I said, for example, 28% of doctors think base jumping is a good idea. You with me? If I had 100 doctors, that would mean 28 of them thought so. I probably have more than 100 doctors, right? So the whole idea here, one way to look at this is that percent symbol. What we've done as humans, we've said, I need to make a bigger number to make more sense to me. So if I told you that the ratio comes out to be 0.01269, that doesn't mean a damn thing. But if I said 1.269% of people do this, you have an idea what 1% means, right? Especially now that we had the whole Occupy movement, right? The 1%. So 28%, that percent symbol means out of 100. 28 out of 100. So if I actually had 50 doctors, let me see if you guys can get this. If I had 50 doctors, how many of them would say it's a good idea? This is from a chapter back. How'd you get 14? Yeah, you cut this in, divide that by 2. So what do you got to do at the top? Divide by 2. Exactly. So we're going to see a lot of similarities between how percentages work with how fractions work, because that's what percentages are. And they are also decimals. Yes, sir?
Boy, 50% of zombies eat another zombies.
We can bring zombies in if you want to. We'll do that in a minute. So let me take a step back. How many people are getting 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. That's freaky. We got 28 people. It's going to freak me out. We're going to lose one? Oh.
Okay, 27%.
I got 27 people. So guys, stay with me. We got 27 people in here. How many of you guys own a pet, for example? We got 1, 2, 3, 4. Keep it up. 5, 6, 7, 8, 9, 10, 11, 12, 13. You got one? That's funny. You're sometimes I have a pet. So 13.
I got you.
So if I can say it like this, the section, guys, you can see why we came right out of chapter 6 to here. If I say 13 people own a pet out of 27, how can you write that? How can you represent that?
13 over 27.
13 over 27.
Wow.
Now help me out. What is that as a decimal?
13.27.
No.
$11.1.
13 divided by 27 comes out to be
0.4, I guess. 481,
481, 481?
yeah.
Neither. All right, good. So it's about that, right? Yes, sir.
That's a half of the zombie population.
All right, let's stay away from the zombies. Let me take that off. Let me round it to the hundredths place. Are you guys with me? So that's why I got that little symbol there. It means it's about 0.48. You with me? Is that cool? What is that? How do I write that as a fraction?
48 over 100.
And now we know that. Now we know that out of 100, I can replace it with what?
48%.
Exactly. Out of 100, this thing takes the place of out of 100. That percent symbol just means out of 100. So it's sort of like making the numbers bigger. It's taking the division by 100 out of the way. So this 0.48 blah, blah, blah becomes 48 of 100, which is 48%. Which makes more sense to me. Percentages just make more sense to people. Right? I can kind of get a feel for what they mean. That's almost half.
Yeah, it makes sense, because 48 of 100 is just 40% of 100.
Exactly. So I'm trying to make everything kind of like relative to out of 100. That's what percentages try to do. And sure enough, what would half of 27 be? Well, let me try this. What would 13 would be half of 26.
Yes.
So it's a little bit less than half of 27. So it's 48%. It's almost 50%. 50% would be half. I love it. Why is 50% half? What's that percent symbol mean again?
100.
Out of 100. And what does that reduce to? A half. Cool.
Awesome.
So there's a couple of things that are kind of hidden in what we just did. And I want to make them more general, because you're not always going to get decimals that stop at the hundreds place. You've got to kind of know how this works in general. So if I want to convert a decimal to a percent, here's how you do it. Since that percent symbol means out of 100, I'm always going to move that decimal by 2. I love it. So if I have 0.48, it's going to become 48%. If I have 0.01, 1%. You guys with me? Or any sound effect you want? Yeah.
Okay, good. 1%. Okay.
Thank you for that comment. So if I had 1.29, that's where people start to lose faith. 129%. I love it. Now, there's always situations where you cannot have more than 100%. I can't say 129% of us, like, no. I can't have more than all of us. And all of us would be 100%. So what situation would this make sense for? Can somebody give me a situation where it would make sense to have 129%?
He was out of 1,000?
No.
Uh-huh.
Percentages are always out of 100.
You know the saying when they're like, you gotta give it 150%?
Say again? Yeah, that saying is insane, but it's more of a perception thing, right? It's more of a human perception instead of a...
When percentages go over 100?
So one situation would be, you can't have something like I say, such percent of people like this. Because the most you can have of people is 100% of people like this.
Okay.
But you could say prices went up by 129%. Which means they more than doubled.
Yeah.
If something goes up by 100%, if it costs $5 now, 100% of 5 is 5. So 5 plus 5 is 10. It's now twice as much. So if I'm talking about how much something has increased or decreased, it could certainly be more than 100%. You guys kind of with me?
Yeah.
It's like gas prices around here, how it goes up and down. Yeah. So, I want you to notice something. Since percentages are related to out of 100, and 100 has those 2 zeros, you're always going to be moving that decimal place twice. The really nice thing, and let me see if I can do this without anybody taking a different interpretation. If you want to go from decimal to percent, or from percent to decimal, if you just write those in alphabetical order, the direction you have to go is the direction you move the decimal. What the hell do I mean by that? 0.48 is a decimal. I've got to move the decimal this way. 48%. If I gave you 1.2%, now I want to go from percent to decimal, I've got to move the decimal that way. How many times?
Twice.
Always twice.
Twice.
So 1.2% would become
60%.
0.012. How we doing? Yes, sir.
What if you have thousands?
You have to make it out of 100. So we're going to get to the point where we have from fractions to percentages, right? Percentages are always out of 100.
I know, but like, what if you have 0.482?
All right, 0.482.
You move it twice, so you get 48 point.
No. So you mean if you have a decimal?
Yeah.
All right. So you move it twice.
You got 48.2.
So you got 48.2%.
That's it.
Not a big deal. So I desperately want you to understand this. If it starts off as out of 1,000, the percentage is just the out of 100 part. There's always that leftover piece at the end there, right? The percentage can only move it twice because the percentage was created to mean out of 100. You can only move it twice. So, if I had, let me give you a few more of this. You guys try these. Hey guys, try these for here.
You made them harder than first grade.
You picked up on that.
7.1.
I don't know if you noticed, but I always do that.
Yeah, I pay attention to detail. I don't like it sometimes. That's not good, but this is Math Academy and Math Box too. About math.
Mad About Math, yeah. How old are you? You remember that Mad About You show? Is that what you're doing?
I'm pretty old.
Oh, you just showed it.
That's all the rejuvenating cream I use.
Okay.
Let me make sure everybody's on the right track. How's this first one work?
91%.
99.1%.
Yeah, once, twice. Now, real quick, guys, do you like 0.091 better or do you like 9.1% better?
9.1%.
So this is why humans made up the idea of percentage. It doesn't mean that it doesn't mean anything. We made up the idea of percentage so that it made more sense to us. 9.1% means more to me than 0.091 ever can. We just can associate it with it better. You guys kind of with me? It takes some of this 0.0 stuff out of the way. So what about going the other way?
2.178.
Once, twice. You always got to move that thing twice. So now it's going to be 0.2078. So what about this one?
0.11%, 1,100.
11.17.
Yeah, so once, twice. So again, if you're going from decimal to percent, another thing I sometimes say is, if you go from decimal to percent, you're going to make the number itself bigger. 48.2 is bigger than 0.482, you with me? So if you go from decimal to percent, you're going to make it bigger, because you're going to move the decimal that way. The other way, you're going to make it smaller. So what about this?
0.0091.
Yeah, this one kind of sucks, because people look at it and say, it's already small, I must have to make it bigger. But no, you got to do it, you got to move it back twice that way. Cool. Because 0.9% is not even a full percent. So the decibel's got to be really damn small. It's not even 1%. Poor little dude. Yeah.
I understand.
So you're always thinking move it 2 places to make it a percent.
Good. I like it.
No matter what.
So, let me tie some stuff together. You ready?
Ready?
So, remind me, what does it mean? What do I do when I divide something by 100? What effectively happens? Why do I not have to do any work, really, for that? If I have 14.9 divided by 100, what's the quick way to do that? When I multiply by 10, when I divide by 10, what happens with the decimal place? It just moves, right?
1.
So when I divide by 100, the decimal place moves twice back. It makes it smaller because I'm dividing by 100. You with me? When I multiply by 10, I just have to move the decimal once, make it a little bit bigger. So this would become 149, yeah. So if I had 10 times 0.027, what would that be?
0.27.
Good. You move it once, bigger. 0.27. So what we're doing is this. If I have a percentage, like 13%, I know that that percentage means out of 100. And when I divide by 100, mathematics says what's going to happen, because our number system is based on 10, it should be easy. I shouldn't have to do long division. Divide by 100, they just take the decimal
0.13.
back twice. So it's 0.13. Yes, sir?
It's not 87.
No, it's not 100 minus 13. It's 13 divided by 100. Divided by 100.
But I don't understand.
So real quick, what's 3 divided by 10?
7.
No, not 10 minus 3. How do you write 3 tenths as a decimal?
2.
0.3.
0.3.
What?
So what happened to the decimal? Didn't it go back? It went back once. You with me? When you divide by 10, the decimal goes back once.